So we continue with advanced pandas now. So 2 lessons ago, we started to learn pandas, and I hope that by now you all feel more comfortable with the framework and started working with it and seeing how useful it is. So in the first lesson, we covered, I would say, maybe 80% of the features. Not strictly 80% of the features, but like 80% of the main features, say, of pandas. And today I want to cover the 20 remaining percent of main features, and really re-end our discussion of this framework. So we're going to cover some topics which were a little bit more advanced, so I wanted to keep them to this point where we feel more comfortable with the framework. And let's begin with grouping and aggregation. And as an example, as usual, we're going to work with our absolutely favorite, most beloved data set of ViperDB. So you can download it. Yeah, as you realize by now, Pandas is a framework to work with ViperDB, and that's what that's what it's good for. So let's see an example that we actually saw in the previous lesson when we worked with matplotlib, and we wanted to calculate the average. It was the inner radius of viruses per family. And if you remember the first lesson, I told you that I actually recommend you to do anything within the framework of pandas, and I don't recommend you to write for loops. And then just on the next lesson, I wrote a for loop, which for each family within the unique families you see here, in this list comprehension, we query all the families with this specific family, all the viruses with this family, and take their inner radius and calculate the mean. And with the tools we've seen up until now, that's actually the only way we can do such a thing. If we wanted to calculate the inner radius average per family, then we have no choice but to use a for loop, because we've not seen any way to do it internally within the Pandas framework. So that's the motivation of now we want to see how we can actually do that within Pandas in a way that is easier and nicer to work with, and also crucially much more efficient, because everything is more efficient when you continue to work within the more efficient Pandas framework. So let's see how this works. So for that, we're going to use a tool which is called a groupby. And what we actually want to do, we want to group our records per family, and then to query the inner radius of each group and calculate its means. So we want to do some aggregation per group, and that's the syntax you see here. So what we do is viperdb.groupby, the name of the column that we want to group by, and that gives you back something that is called a groupby. We'll explain later what exactly this gives you. But let's first begin with a more intuitive way of using it. So whatever this gives us, we then query the inner radius column, and then we want to calculate the mean. And here I just show you the first 10 records, but of course it contains a record per family, and what we get is exactly what you expect. You get a series that is now indexed by the family, which you group it by, and with values, you can see according to the name, is the inner radius. So it's the column that we queried and then calculated the mean. So we see actually the mean per family, and it's all done within the Pandas framework in an instance without us having to write any for loop. And you can see, you can appreciate that it's much simpler than the code you see here. And also, as we're now going to see, it's also much more efficient. So let's try to measure and to benchmark these 2 options and see which is more efficient using the time it magic. So you can see that the first option, where we had to write this for loop, this takes approximately 14 milliseconds per loop, whereas the second option is only 600 microseconds. So it's it's almost 30 times more efficient. Just this simple example, and here we don't have all that many records. Now, there is also a technical reason why it's more efficient, and also more deep algorithmic reason. So the technical reason is, of course, we work within Pandas, and we said Pandas is more efficient than Python. But there is also like a deep algorithmic reason why this is not efficient to do it the first way we saw it. If you try to actually think what this code does when we write this with a for loop, you can see that we run for each family, and we have, 30 different families. And then for each family, we use it to filter the exact data frame. So when we do that, when we create this mask, comparing the family column to family, we actually go through the entire data set. And we do that as many times as we go through the families. So for each family, we iterate through the entire data frame from scratch all over again. And that's like a more deep reason why it's not efficient. So we actually go through the entire data frame like many dozens of times instead of doing this just once. And for each record, like figuring out what family it has, and then like doing this this indexing on the fly as we just go through it just once. And that's actually what the groupby does. When we group by something, it doesn't go through the data frame over and over again. It just goes through the entire data frame once. It indices, it creates this inner index of like each record, what group it belongs to, and then using this inner index, it queries each group just as it needs to, and not going through the entire data frame all over again. Okay, and that's why this is much more efficient. Now, in the previous example, we queried a specific column, and so at the end we got a series showing the mean per group. But if we don't then query a specific column, we just group by and then calculate the mean, then it will get the mean of all the columns. And the result will be a data frame, like you see here. So you can see that for each family and for each column, each numerical column, we get the average of this column within each of the families. Now, we might also be interested just in the size of the family of the groups, namely how many records we have of each various family, using the size function of the groupby. But that really would give us just something that is equivalent to using the value count of the series, which, if you remember, we learned 2 lessons ago. So actually, if you just want to count how many records you have of each column, then it's better just to use the value counts of that column. But we're later going to see that sometimes we can group by more complex stuff. For example, we can group by a combination of columns, and then calculating the size can actually be meaningful. We can also do more than one aggregation. So here we just took the mean or the size as some aggregation, but we can also do a few together. So for example, we can group by family and then query the inner radius and then run 2 different aggregations. We want the mean and standard deviation of each group. The way we do that is using the AGG function, which then gets a list of either functions or strings which refer to specific functions. So here we see it with just string representation, so mean standing for the mean and std for standard deviation. And you see we get a data frame that for each family gives both the mean and standard deviation. And we can even do that without querying a specific column. And then we'll get the mean and standard deviation of each of the different numerical columns, like you see here. And then you will have this layered column, what is sometimes called a multi-index, and we're going to look into it in more details later now. But for now, just notice that you have these 2 layers, and for each column, you have both the mean and a standard deviation. And you can actually get that for all the different columns, for all the different families. Now, the AGG, like I said, it can also receive a function. So I can give it a built-in function like the NumPy average, or I can even define my own function that has to get the values of the group and then do some logic with it. So in this case, I just created a function that, given some values, will sort them and give the second largest as the value. And you can see how it works now for each family and for each column. These functions are called with the relevant values. So for example, if we have a family with 10 values of these viruses, for example. So then for the subunits, we'll get the 10 values of the subunits. And these values will go to these functions, and they will perform the logic, and we'll get back the result. And you can see that it even gives them appropriate titles according to the name of the functions. Questions until now? Okay, so we've seen many uses of this groupby and what we can do with it. And I want to spend a few minutes to actually try to understand what the groupby actually returns. So when you do groupby, what do you actually get? So you can see that if we do viperdb.groupbyFamily and store it into a variable and then print it, we see that it's actually its own kind of type. It's a specific class, which is called a dataframe groupby, and that's the thing we actually get when we do a groupby. So it's not a dataframe and not a series, it's something, something different. So let's try to see what this type is and what it can do. So one thing, for example, we can do, you see that the family groups has a member, a class member, which is called groups. And you see that it's actually just a dictionary mapping the name of the groups, the values of the different groups, in this case just the family values. For each of them, it maps into an index of all the records with that family. So you can see that the adenovirus virus has 10 records, and you see their indices here. And then the second family has 5 indices, and so on and so forth. So the groups actually gives you like the inner structure of what data the groupby actually stores. And that's the index that I told you about. So when we groupby, what Pandas actually does, it goes through the data frame, and then for each record, it figures out to which group it belongs, and then it keeps this internal structure, mapping each value of the groups to the appropriate records. And now if we want to access specific groups, it can do that instantaneously without going through the entire data frame, essentially. It can just go to this dictionary, to the relevant group, and then pick the relevant index, and using this index to get the relevant slice of the original data frame. So now that it has this internal structure, it can do any aggregation or any other functionality that we want without going through this data frame again. So it keeps this nice index that we can then use on demand. For example, we can just ask for a specific group using the getGroup function of the family groups which we created. And then we just get the relevant data frame. So this gives us something which is equivalent just to filtering the original data frame. So if we take the original data frame and we filter it the way we saw, using the same virus family name, you can see that we get, again, all the records with that family, which is exactly what we get if we use the getGroup function, like here. But the only difference is that in this case, it will be less efficient because, again, we need to iterate through all the records from scratch to create this mask. And in this example, it just uses the prepared index that it has internally and can just query the relevant records, again, instantaneously without us having to do this heavy loop again. And we can even iterate through all the groups at the same time. So if we just treat this groupby object as an iterable and try to do a full loop on it, we actually can iterate through the different values as pairs. So we can, the first value within each tuple is the family name, the group name, and then the data frame. And this name we can iterate through family name and then the relevant record as a data frame. Now don't print here the data frame because it will be too large, but you can see that for each family we get its own data frame. And we can just iterate through, again, if we just want to iterate through all of the groups, we can just use a for loop. And again, this will be much more efficient than each time to query it again from scratch. And here you have some benchmarking, which will prove it to you. So in the first example, we iterate through the unique families, and then for each family, we query the original data frame using this family. And then in the second example, we just use the groupby to iterate through the sub data frames. And again, you can see quite a substantial factor that the second option is much more efficient. And here we just have a few dozens of families. If we want to group by something which has, for example, I don't know, thousands of values, this can become very, very, very substantial. So it can really make a huge difference if you do it efficiently or inefficiently. OK. Like I mentioned, we can group not just by one column, but by multiple columns at the same time. So for example, here you can see that if we group by the genus of viruses, we get 71 records. But if we group by both the family and the genus, we get a more fine-grained grouping, which gives us 74 records. OK, so even though genus is a lower taxonomy group than family, so you would expect maybe that grouping by both family and genus would be equivalent to grouping by genus. It actually turns out that you have different virus families with the same genus names, in this data frame at least. And using this groupby will actually give us the right taxonomy partitioning that we want. OK, so the way to group by multiple columns is just to give a list of the column names. And now each group will be a unique combination of family and genus. So even if we have two records with the same genus but different family, then they will become a different group in the second example. And you can see that now if we do some aggregation on that, for example, if we call the mean function to calculate the mean within each group, you see that now each group is characterized by both the family and the genus. Again, this is what I alluded to earlier. This is the multi-indexing, which I will explain later. But for now, just notice that you actually have two index values for each record. And then you can see the mean of each group across all the different columns.
Is the order of the family and genus, is it important? Because if we do it by genus as well, it will look differently.
Yeah, if you just grouped by the genus, you would get 71 groups, whereas here you get 74 groups. OK?
No, I tried to ask a different question. But what if we have indeed two genus with different family?
Mm-hmm.
So if I wanted to be, now it's ordered by family and then all the genus.
Yeah. You ask about the ordering. I think that by default, the way it works is that it will order by the first and then by the second. So, OK, so you can see that the family is ordered alphabetically, and within each family, you have an alphabetic ordering of the genus. OK? OK, let's see a slightly more complicated example of where we can use it. So what we do here, we want to plot, like you see here, for each family, we want to plot the average of the three types of radiuses, the outer radius, inner radius, and average radius. Like you see here, each one in different color. And for each one, we also want to see a standard deviation as an error bar, like you see in some families which have more than one record. So for example, here you can see it has some standard deviation. Now, there is a problem, however, that if we group by families, then we can create a bias that some genera are more represented than other genera. And in particular, within the ViperDB, there is a technical problem within this database that it takes, the way it works, it's based on structural data of crystallography of viruses. And many of the records from PDB, by the way, and many of the records, they're not actually real living viruses. They're just artifacts of virus particles which didn't really assemble correctly. And then you just get this very small kind of apparent virus capsid, which is not really a living virus. It's just some collapsing capsid proteins. And actually, many of the records in ViperDB will be these sort of artifacts. And it's very common, actually, to have some genera that have some strains which are real viruses and some strains which are not real viruses. Now, a good way maybe to overcome this is to take the maximum value within each genus. So if a certain genus has, say, 20 different records, then since genus is quite a close taxonomy group, then we can expect that normally, like if we work with valid living viruses, we would get more or less approximately the same size of the different metrics that we use. And if we get something that is substantially lower, then most chances we're dealing just with an artifact of something we don't really want to take into account. So a nice way to overcome this will be within each genus, we just want to take the maximum value. And then we're pretty sure that we work with something which is actually real and a real virus that we actually want to measure. And this way we also make sure that we get a good representation of all the different genera. So we don't have one genus which is dominated, say, we're not dominated, say, by one genus which has 20 different records and a different genus that only has 3, and we have the larger one dominating the second one. We actually want to give a fair chance to everyone, and we want to give an equal weight to all the different genera. So for this reason, we actually do this analysis in two phases. First, we want to group the records by genus, and within each genus, if we have, say, few records, we want to take the maximum value, which we think most probably will represent the real value of these genus. And only then, once we determine the values within each genus, we want to group them by family, and then show the statistics of the mean and standard deviation within each family, like you see here. Okay, so let's see how this two-step analysis can be done quite easily within this group by framework of Pandas. So the way we do that, we first group by family and genus together, again, because we, like we said, that's the best way to really characterize specific genera. So we make sure that they have the same family and the same genus. So this will give us the different genera groups. And then we only query the 3 metrics that we care about, the outer, the inner, and the average radius. And we take the maximum, like we said. Now, if I run this code separately, you can see what we actually get. You see that now for each genus, again, which has these 2 indices, we get the outer, inner, and average radius, and this will be the maximum within all the different records. Let's limit this. Okay. And then to get the family groups, first we reset the index. The reason we reset the index is we want these 2 columns, which are now part of the index, we want them to be regular columns again. So you can see here, this resets the index and makes the family and genus like any other regular columns that we can work with. And then on top of that, we group by the family. So now that we have the maximum within each genus, we can do the family level aggregation and group by the family. And now we can take the family groups and calculate their means. And you can see that what this gives, we get for each family, we get the mean of the three metrics after we have already chosen the right representation within each genus. And then on top of this data frame, we simply call the plot function, which, like we saw in the previous lesson, is just a shortcut for using matplotlib within Pandas. And we say that we want the bar plot. And we also give the y arrow, which will be the same thing, just with the STD, the standard deviation. So again, this is the same groups. We use the STD aggregation, and that gives the standard deviation within each family. So the two should correspond. So the two will give us a data frame with the same index and the same columns. And so we can use one of them to determine the bars themselves, and the second one to determine the error, these sticks that you see here. And that's what produces this overall nice figure that you see here. Now, even though it's not a lot of code, this is a somewhat complicated kind of analysis. And I think this really illustrates very, very well like how powerful this package is of Pandas, and like really the complex things you can do with really, really little code if you are familiar with it and you know how to work with it and what you want to do. So if I asked you, by the way, to do this analysis before learning in Pandas, I wouldn't be surprised if it would take you like maybe 100 or 200 lines of code just to do this thing, because it really involves many steps. So you first need to go through the genera and then determine unique genera and create maybe some dictionary to do this mapping. And then within each genus, you'd want to do this aggregation to store it into a different variable then, which will give you the maximum value. And then you want to use these values. Again, you'd have to iterate through all of them to determine the different families. And then to do the aggregation, it would really take you a lot of time to do this, to implement this logic. And not only it would take you a lot of time, it would also be probably not very efficient and take the computer a lot of time to execute it, because it would be probably many layers of loops and a lot of Python code. So I think this is really a very good illustration of really how Pandas can do life a lot easier for us. Any questions? OK, so to summarize this discussion of the groupby, I put you a link here that you can read more about this. So there is this Pandas tutorial about groupby and how to work with it. So I covered, I think, most of the basics, but if you want a more in-depth look of how it works and more examples, you can visit this group and see their tutorial. Like I said many times, they have really great tutorial. And I think it's very easy to just see their examples and see how things work.